Next one, what volume of SO3 could be made from 1.15 liters of SO2 and 0.65 liters of O2 according to the equation below, which is balanced, if all the gases are at STP? Okay, now notice we are given amounts of the two reactants here, but nowhere does it say they're in the right stoichiometric ratio. So that means we have to do one of your favorite things, right? Assume that it's a limiting reactant problem, treat it accordingly, and take each one of these, assume it's a limiting reactant, figure out how much SO3 you could make from it, and the one that makes the less SO3 is in fact the limiting reactant, right? Now, here's where everything's different. Instead of trying to go through and calculate moles, I've got STP right here, so I could figure out the number of moles of SO2 and the number of moles of oxygen, and I could go from there, and it wouldn't be anything new or different. All right? But I also have Avogadro's principle that I could work with, and that says, at a given set of conditions, the volume of gas is proportional to the number of moles. So at STP, 2 liters of SO2 should react with 1 liter of O2 to give 2 liters of SO3 according to the balanced chemical equation. Liters react with liters to give liters. That's cool. That's different. All right? Now, we aren't given 2 liters of SO2 and 1 liter of O2. We're given 1.15 and 0.65. So what we'll do is use the stoichiometric ratios here from the equation, and we'll do a conversion of, first of all, SO2 volume into SO3 volume. Why doesn't he say moles, you're thinking? Right? We don't need moles. Right? We don't need it because volume is proportional to moles. So we can work directly in volume. And it turns out to be simpler, easier, and quicker when you have this kind of conditions, where nothing changes. Okay, so it's a limiting reactant solution. We try both, limiting reactant situation, we try both reactants. First of all, we will assume that O2 is in excess. We'll take 1.15 liters of SO2, we'll multiply it by 2 liters of SO3 over 2 liters of SO2, and that will give us 1.15 liters of SO3 if there's excess oxygen. Right? Or, if we start with oxygen, 0.65 liters of O2 times 2 liters of SO3 per 1 liter of O2, that gives us 1.30 liters of SO3. That's obviously more than 1.15 liters, so that means SO2 gives a smaller volume, and SO2 must be limiting. And if SO2 isn't limiting, then we can take the volume of SO3 from it. It means the O2 must be in excess, and then all we have to do is write down the answer. Right? It's STP, so we don't even have to convert anything. So if you have a circumstance like this, it takes fewer steps and there are less chances for error.